Hello, good afternoon. This topic should be presented by 3 speakers, but 2 of our speakers have not come here. So I will present this slide. My name is Cao Yuhuan. I'm previous PTL of Tricycle and OPNFV Multisite. I'm working for Huawei. The other 2 speakers are Valentin and Vikram. And the slide was prepared by 3 of us. In this session, we will review our practice, how to move the mission critical to multi-site cloud. There are two applications have been done in the practice. One is VMS, the other one is Jitter C. These 2 applications mainly for video conference and voice. For VMS, we use the open source Clearwater. The Clearwater VMS is IP-based voice and video and message service. It's just like ETSI defined IMS, but it's developed in open source. For VMS, there are several components. This Bono is the component to handling the connection from the UE. UE will initiate SIP call or WebRTC-based SIP call and connect to Bono. And Sport is mainly to deal with the service. And LAF is to produce the billing information. All calling record will be sent to the CDF, the charging data. And Homer is XDBMS database. All this kind of document will be stored in Cassandra. And the Homestead is the component to store the user profile or retrieve the user profile from the external HSS component. So these components are all designed with high availability mode. Each component can run multiple instances with load balance mode. And the back-end data will be stored in the Cassandra. This architecture is the old architecture. When we deploy this application to 3 cloud, we use the version before May 2007. Later, this architecture has been updated. So if you visit the Clearwater website, the architecture is a little different. But the core idea is that to store session data and user data in Cassandra-based database. This is a very important design. We can see how it works in multi-site. In our practice, we deploy the VMS in 3 clouds. For manual, the Cloudify is to deploy VMS and monitoring VMS. For Cloudify Manager, it's not deployed with redundancy component. And Alice is an experiment portal to provision user data. And the DNS is to do the name resolution. Okay, this component is some components outside VMS, so it's deployed without redundancy. But for VMS, all components are deployed with redundancy. In one site, multiple instances of each component are deployed. So, and all components will be deployed another copy in another cloud. So the whole system is deployed in 3 clouds. When the UE or mobile phone or web-based RTC to initiate calling, all the call requests will be load balanced between different clouds. This is achieved by we have a geography redundancy database. We use Cassandra to replicate the data between different clouds. So all the call requests could be load balanced between different clouds and different components. And all components can see same data set. This is the very important point for the high availability application in multi-site. When one site is crashed or components in one cloud crashed, stopped working, then all the requests and the established session will be served by the healthy one. Will be served by the healthy one. So this application can achieve site-level redundancy. Jitter C is another application we deployed in the practice. Jitter C is one open source video conference. This session is a 3-party video conference. 3 people talk together through the video conference system. And this one is a 2-party video conference. 2 parties can talk with each other with the video. For Jitter C, it's designed by several components. Jitter C Meet is the web front for the application. And it's running in Nginx. And Jitter is for the conference management and Prosody to process the XMPP message. The real video connection will be handled, the stream will be handled by Jitter C Video Bridge. So when we deployed the Jitter C into 3 clouds, we deploy the controller components like the Jitter C Meet and the prosode. These three components, we call it a Jitter C control. So we deploy it in one cloud, and the Jitter C video bridge in another two clouds. When a new user creates a new video conference through the web interface, if another user joins the conference, the video stream will be happened in scheduled Jitter C video bridge. So the two guys can watch with each other and talk, and even including text message. If more people join, the session can still be handled in the Jitter C video bridge. And the Jitter C control will have a health check heartbeat to monitor the Jitter C video bridge health. If one video bridge is broken or shut down, the health checker will find this component is not healthy. So all the session will be moved to another Jitter C video bridge. So the conference, video conference will resume in another bridge. Okay, we can. I have recorded one video for the okay, here is the two-party video conference. We can check the status of video bridge. This is in OpenStack Cloud 3. There is one server called Jitter C Video Bridge 2. It's active. And in Cloud 2, the JVB1 is also active. Then we will shut down this Jitter video bridge. When we stop this video bridge, okay, the video conference will be freezed for a while, and then switched over to another cloud. The video conference resumed in another cloud. We can check, okay, the controller is still active, and the server in OS2, Cloud 2 active, but 3 is shut down. This is a three-party video conference. You can see we can experience a similar service resume. Okay, when we stop the one video bridge, the video conference will be freezed for a while. After a while, it resumed in another cloud. So what we learned in this practice, let's talk about the experience from three aspects. The first one is the infrastructure layer. How the infrastructure support the application high redundancy across different clouds. Then we talk about the application aspect and the orchestration aspect. For infrastructure layer, we use tricycle to create the cross-neutron VXLAN network. The VXLAN L2 network is created through the shadow agent and the shadow port. We use the shadow agent to cheat the Neutron server. So the Neutron server may consider it has one agent, but it's not exist in this Neutron because no real host is bound to this agent. And the shadow port will be bound to the shadow agent. So the shadow port will be filled with the shadow agent VTAP. And the shadow agent VTAP is existing in another Neutron server. So when we create a shadow agent and the shadow port in this Neutron, after the L2 population or other layer 2 networking technology, this Neutron will know the VTAP of this port in another Neutron. So tricycle help application to establish the cross-neutron VXLAN network. We have one session yesterday about a tricycle project update. More detailed information about the cross-neutron VXLAN network. And for layer 3 networking, we use the shadow agent and the shadow port to create a bridge network for different router in different Neutron. So different router can be interconnected through the VXLAN-based network. And here, the shadow port is based on a gateway port. We use the external network of router to work as the bridge network. This is the networking for the Jitter C, the first application. For Jitter C control, we will have one floating IP in the cloud 1. And the Jitter C control is attached to a local network, net 1. For Jitter C video bridge, they all have one floating IP for video stream. Video stream will be established through the FIP here. And Jitter C control and Jitter C video bridge 1 and 2 will be plugged into one cross-neutron layer 2 network. Each virtual machine has two interfaces. Another interface can communicate with each other through the class OpenStack VXLAN network. But north-south traffic will go directly through the local router and floating IP. So this layer 2 network is mainly for the heartbeat. If Jitter C control detect the Jitter C video bridge is not healthy through the heartbeat, then Jitter C control will switch. We will ask the client to re-establish the stream in another healthy bridge. Why? Okay. The network topology for VMS is different. Jitter C is based on the layer 2 network. But for VMS, we create a cross OpenStack layer 3 network for VMS. Cloudify, DNS, and Alice were deployed in region 1. In this region, there is one network, local network. And the local network will be connected to two routers. One router for local north-south traffic. And the other router will be responsible for east-west traffic. And the VMS in another two clouds will also be attached to this network. And this Net 2 and the Net 3 local network also connected to two routers. One is for north-south traffic. The other one is for east-west traffic. Tri-circle will help to build the east-west traffic through the non-local router. The green one is the west router. So all the service provided to external world by the floating IP in this blue router. Cassandra's data will be replicated through this network. This is one internal network for the data replications through layer 3. Okay, so the consideration for application west-east traffic in multi-site is that the first one is you must keep it secure. So we use dedicated line or list line for the east-west traffic. And the traffic must be isolated between tenants. If multi-tenant or multiple application deployed in the cloud, we have to isolate the traffic. So we use layer 2 network and the layer 3 for the isolation. Different tenant can only see his own network and the router. And the most important one is that the network quality should be very good for east-west traffic. For heartbeat, if there is packet loss or JIT LAN, the application may have mistake on the component's health. So we need a steady network quality for the application east-west traffic. How to establish the east-west network? We propose that set-to-set VPN or dedicated line could be established between different sites. LAN use the VX line or layer 3 network or bridge network to do the isolation between different tenants. And the north-south traffic can be handled locally or by the floating IP in the north-south router. But for east-west traffic can go through the bridge network. In application level, there are also some consideration to achieve a set level high redundancy. For Jitter C, we mainly deploy the VNF and the network from single API endpoint. Slow tricycle, one endpoint can be provided to establish the network topology. And we also need a CQ, a logical layer 3 network between Jitter C controller and video bridge. So we use the east-west traffic, so the internal layer 2, layer 3 network can provide a good network quality. And the heartbeat over the private network. And the control information can be processed in internal network. A public network for video stream and between user and video bridge. And the floating IP and security group configuration for different sites and for different type traffic. For TCP for control and messaging, and UDP for audio and video stream. So we need to configure some security group ruler. For VMS, the application itself must take into account about the multi-site constraint. Security. We need to ensure the data storage and replication between the Cassandra must be secured. So if the data is replicated through the public network, then the security cannot be guaranteed. Another one is the application should be designed with high redundancy and consider the site level high redundancy. So we use load balancing and fault tolerance mechanism to design the application. And we use the backend database which can be deployed in different sites and realize geosite replication. Cassandra can be deployed in this scenario. And we also need to consider the north-south traffic and east-west traffic priority. North-south traffic should be processed locally as much as possible, only as less as much possible for east-west traffic. We should reduce the data replication between different sites because the replication will be very important to make a decision whether to switch over the traffic or not. And another one is we need to consider how to configure the application in different sites. We need to keep a consistency configuration in different components for same application because this application will be deployed in multiple sites, but how to manage it and how to do the configuration change, it should be kept in mind. We must verify it in the first site and then apply to other sites so that the application can work with load balancing. For orchestration layer, currently the Cloudify is not deployed with multiple instances. Only single instance is deployed in Cloud 1. We hope that in the future it could be deployed with multiple instances working in a load balancing model. And monitoring and scaling is also very important. We need to monitor the load in different sites and to make a decision how to make the traffic could be handled balanced. And it's also very important to deploy the virtual machine in the right site. Sometimes we may create some virtual machine in some site, but did not process it properly. So we need to consider which kind of components should be put in which site. And the best one is that all sites keep the same structure. Okay, there are more information can be obtained through the website. We have all the stuff shared in the YouTube or Google Doc. So you can watch the video we have produced for this practice. And some documents could be obtained in Google Doc. And for tricycle, you can find the documentation and the website in the internet. And you are welcome to join the community. Okay, thank you. Question? Okay.
Sorry, I think you haven't mentioned about how you load balance. You actually do the load balancing between multiple sites?
Mm-hmm.
The load balancing between the multiple sites. So when the UE wants to access like the site 1 and site 2, like how does it actually get load balance between both of sites?
Site 1, site 2. I don't understand your question.
If you can go back to the
Which
the slides, I think the second or third. Yeah, that one.
This one?
The previous one. That one we assume that the OpenStack Cloud 3 is off, right?
Yeah, Cloud OpenStack Cloud 2 is in one site and OpenCloud SD in another site.
Yeah, so it's not available, so it's black out. Is that right?
Mm.
So all the request goes to OpenStack Cloud 2?
Yeah.
But in the previous slide?
Another.
If you go to the previous slide, just one slide before.
Pardon?
No, just one before that.
This one, yeah.
No, next one, I think.
Okay. All the traffic will be incoming by DNS, so it will be load balancing first. And then if the part of them stopped, then the session will be reconnected to another Bono.
Yeah, so where is the load balancer located?
This one? Yeah. The MS itself can re-establish the session in another bono. Yeah.
Okay, all right, thank you.
Yeah. It's the capability of application itself to rebalance the traffic. Yeah, it's not the tricycle or OpenStack to move the traffic. Application move the traffic. Just like Jitter C, it's also handled by the application itself. Yeah.
I just wanted to ask about the cluster distance. How far away are the two clouds from each other? Geographically, how far?
Pardon?
How far is the two sites, the two cloud sites?
Yeah.
How many kilometers away?
I can show you how it works like this. The traffic will go through the SD router, and we will populate the host router in net 2, so the instance can get a router to SD for net 1, and by default, the traffic will go locally to the R2. So north-south traffic will go to R2 and the external network by default. But to another OpenStack network, there is one host router in the network. And in the router, we also have one concrete extra router to next hop to this router's to this port for net 1. So the traffic will go from the net 2 to SD2 and the line to the Beijing network.
So the question is, how far between the different clouds, and maybe is in the same data center or different location data center?
There is no limitation on the distance. It's up to how often the application will judge the heartbeat. For example, if the heartbeat is 100 every second, then the distance in different data center, the latency should not be longer than 1 second. So the distance is determined by how far the data should be replicated and how much data should be replicated in limited time window. If there are very few data needed to be replicated and the heartbeat interval is very longer, then the network latency is not a bigger problem. But if the heartbeat and the data replication is very sensitive to the network latency, then the distance for the different clouds should be as close as much. For example, in smaller than 200 kilometers or less than 100 kilometers, then the latency should be as less as much, for example, less than 10 milliseconds or 5 milliseconds. Okay.
Depends on application there.
Yeah.
Because in this solution, there are Cassandra's cluster. So I think in a Cassandra's cluster will demand some latency between this geography. And also in tricycle, there is the X job daemon. X job daemons is depending on RPC communications from the central region to the bottom region. There are also need some latency requirements,
Yeah.
I think.
But in all deployment, one OpenStack is deployed in one site, so no RPC message between different cloud, different sites. All RPC message is handled inside one cloud, inside one site. Yeah. Okay, thank you.